All right, first thing, let's write down the section number. So it's section 1.3, and it's broken up into two parts. Okay, it's distance and midpoint. Today we're just going to talk about the distance. And we've kind of already talked about it a little bit, talking about the length of a line segment. Okay, so that's what we're talking about, the distance. Let's pretend this. Let's say we're on a trip. Right? You've been on trips before, right? You're on the highway and you're at a mile marker, and I don't know, your mile markers probably don't look like this, but let's say you're at the 5-mile marker, and then you're driving down the road. Watch, here's my cool car. Look at that. Isn't that cool? Bet you wish you had a car like that.
Oh,
Yeah, go ahead. All right, and let's say this mile marker was, let's say, we'll make it easy. We'll just say it's 15, okay? And you're going down the road. You're going down the road right here, and McDonald's is right here, right? Here's the arches, and you want to get to McDonald's. So you want to find out how far you have to go. Look, this is not brain surgery. This is pretty easy. I'm not trying to trick you or anything, right? If you want to get from here to here, then how do you figure that out? Eric, you already said 10, but how did you figure out 10? What'd you do? What math did you do?
15.
Yeah, 15 minus 5. Right. I told you this is not hard. I'm not trying to trick you up or anything. This is easy stuff. But here you would end up at 15-mile marker, but you're at the 5, so you just go 15 minus 5, correct? Which is 10. Pretty simple. Now, watch. You could have done this. You could have started. You're at the 5-mile marker. You could do what? Subtract a 15, but what would that give you?
Negative.
That would give you a negative 10, but we can get around that. I don't know if you remember this from Algebra 1, but watch, we could put this in these bars. And I think we might have even talked about this. Did we talk about this in the review? I think we did. We had a few problems in the review. What is that? What do those bars mean? Absolute value, and that is exactly right. It makes it positive. So, look, as long as I put it in absolute value, does it matter what order you subtract them in? Doesn't matter. As long as you talk about distance, distance is always positive. You don't say I'm going to go a negative distance. Now, when you get into physics, you're going to talk about things like displacement and things like that. Kenny, are you with me? Yo, Kenny. All right? But don't do that. Put your head up, okay? You're strong enough to keep your head up without help of your hand. All right. You should pay attention. Everybody watching? Okay. Scrappy, you watching? All right, get your head up, please. Sit up. Sit up straight. Come on. That's not sit up straight. Scrappy, come on. Don't make me do this. Sit up straight, please. All right, thanks. Appreciate it. We are going to do distance formula in a second. All right, now what I'm trying to show you is it doesn't matter what order you subtract these things in, okay? What if I called this point, instead of calling it 5, what if I called it x? Instead of just x, let's call it x1. Are you watching? And no, we're going to call it x2. So this is my first x point, because we're going along the horizontal, aren't we? Remember in Algebra 1, horizontal was x and vertical was y? Well, we're just going to call it x. So if I was here at x1 to x2, what is the distance? What is the length? How far is it from here to here? What would I do?
Measure it.
Would I say plus? I would subtract, wouldn't I? Okay, because this is a point and this is a point. In order to find out how far it is from here to here, I would subtract those two numbers from each other. So I would go x2 minus what? x1. But remember, does it matter what order you subtract them in? Not really. So I could have said what? x1 minus x2, as long as I put it in absolute value. Okay? Are you with me so far on this? All right. So if I'm just going in one direction, how do I find that distance? I take one point, subtract it from the other. And it really doesn't matter which one I subtract from. All right? As long as I make my answer positive, I'm good to go. The same thing could be said with going up and down. I'm not going to take as much time on this because you already get the idea. What about going up and down? So let's say that this was y1 and this was y2. What is the distance between these 2 points? You could say what? y2 minus y1, couldn't you? Right? That's the distance going up and down. Or if you wanted to, you could say y1 minus y2. It doesn't make any difference as long as because I don't know which one's positive, which one's negative. But you could always do it like that. All right? That's how you find the distance between 2 points. You just subtract. Now look, some of you guys got your heads down, not paying attention. I need you to pay attention and look up here. All right? Look up at the screen and let's watch what's going on. All right? That's really ticking me off just a little bit. Have a little self-discipline. All right? Stay awake. I know it's not the most exciting thing in the world, but who cares? All right? It doesn't matter that it's super exciting. You have some discipline, stay awake, pay attention, and watch what I do. All right? I'm busting my butt trying to get you to understand this stuff, and I just expect you to be able to pay attention to me. It's ticking me off just a little bit. Sorry, YouTube, for being mad, but that's about as mad as I get right there. Okay, enough of that. All right, so now we've talked about how to find the distance just going in one direction. But what we're going to do today is a little bit more complicated, and we're going to go in both directions. So what I'm going to have is I'm going to have a point. Let's I'll tell you what. Let's just number this, and we're going to put a couple points here. And it's not going to be just going horizontally and just going vertically. If that's all it was, then it would be pretty easy. But it's not always going to be that way. Let's make this a different color. Let's say I'm going to go to this point right here. Where is that point located? I thought I changed the color. I guess I didn't. Is it 2-2?
Yeah.
It looks like 3-2, doesn't it? All right, looks like 3-2.
Right.
And let's say this point right here. You go to the left, which is -1, and you go down.
Terry, Ben Holly, Jonathan Lumpkin.
So it's -1, -3. Okay? What I want to do, and let's make this a different color. Okay, watch. What I'm going to do is I'm going to connect these two dots from here to here, and I want to find the length or the distance between those 2 points right there. I want to find the distance between them. Okay? But it's got two ways. Look, in order to get from this point to this point, I got to go over this far, right? And then I got to go up this far. So I actually got to go in two directions, don't I? Say it. No, go ahead and say it. I think you're onto something.
X1 minus X2 over Y.
Well, you're on the right track there. Let's do this. Let me make this a different color. Watch this. Actually, if I want it, I think I remember it. Watch this. Yeah. Oh, you better memorize it after we're done here. Okay, watch. What if I did this? Could I find that distance from here to here?
Yeah.
Let's do that. How would I find that distance from here to here? Where is this on the x-axis? Where is this point on? It's at -1 on. Okay, and where is this? That's 3. Is it 3 minus 1?
3 minus -1.
It's 3 minus -1. Do you see that? How do you find the distance? You take the two distances and you subtract, or the 2 mile markers, right, or the 2 points, and you subtract them from each other. So this is going to be what? 3 minus, not 1, but what? -1, which it gives you 4. So what's the length of this? It's 4, isn't it? So the length of that is 4. What about going up? Let's do another color. Let's do that color right here. You don't like that color? Let's go that color. All right, watch. All right, look. Let's go to this color right here and watch. Let's find that distance from here to here. Where is it on the y-axis? What point is this at the y-axis? It's at 2. What point is this one on the y-axis? It's at -3. So how do we find the distance between here and here? We subtract. And it doesn't matter what order as long as you make it positive, okay? So let's just do what? 2 minus what? -3. What's 2 minus -3? It's +5. So look what I got. This is 4 and this is 5. You see it? Let me,
add it or just leave it?
well, let's think about this for a second. I'll tell you what. Let's do this. And let me just flip this around a little bit. Give me just a second.
Mrs. Williams,
Oops, that's not
7A
what I wanted.
homeroom is now dismissed to take pictures.
Transform, reflect. Okay, that's what I want right there. All right. what I want to do, I just drew this off to the side a little bit just to kind of give you a better idea, right? Do you see this triangle? That's the same as that triangle right here. So let's put some stuff in here. What did we say the length of this was? The bottom? 4. What was this one? 5. Okay, this is a right triangle. It's a right triangle because this is horizontal, this is vertical. How do we find? This is an Algebra 1 topic. How do we find? Is it 9? The length of that is 9? No. It's the hypotenuse. You're right. It is the hypotenuse. How do we find the hypotenuse if you know the other two sides? This is something you should have done in Algebra 1. Very good. It's a squared plus b squared equals c squared. Did we talk about that in here yet? No. But this is something that you should have seen in Algebra 1. Who saw that in Algebra 1 last year?
I remember.
Okay, good. So what we're going to do, this is, by the way, what's the name of this thing? Pythagorean theorem. Very good. Okay.
25.
Well, let's write it out. It's going to be 4 squared plus what? 5 squared. Let's call it d for distance. Is that all right? We'll call it what? D what? Squared. Let's do this. Yep, this is 16. This is 25 equals d squared. What's 16 and 25? That's 3. That's a 41, right?
Yeah.
So d squared equals 41, but what's d? What do you do to get rid of that
You
squared?
got a 41 squares, right?
Was it? Say it, Nick. Square root. Square root it. That's right. Take the square root of both sides. So what's d? What's the distance? It's the square root of 41.
I never used that.
Okay? You've never done this before?
No, I said I don't have any calculators.
Oh. Well, you can just keep it the square root of 41. I'm okay with that. All right? If you just want to keep it the square root of 41, that's fine. If you want to put it in a calculator, you don't square it. You take the square root of it. Yeah, you can do that in a calculator if you like as well. It's probably 6 point something, right? Yep.
Yeah.
So that's one way to do it. Now look, that's kind of a pain to have to graph the thing and draw the thing out. Would you agree?
Yeah.
What we're going to do is this. You know how we subtracted those things? What I'm going to do, remember how I put that x1, x2, and the y1, y2 earlier? What we're going to do here is we're going to call this x1 and x2. We're going to call this y1 and y2. So let's just take a look at the points. Let's do this. I'll keep this all up here. Let's do this without, I'll tell you what. Let's write it like this. What if I had one point was x1 and y1? The other point was x2 and y2. What we're going to do is this. We're going to set up basically a Pythagorean theorem. I'm going to show you the formula right here. It all comes from this. I'm going to leave out a few details, but I don't think you'll care. Look, what did we do? We took the square root of these. How did I get that 16? Well, I got a 4 first, didn't I? How did I get that 4? I went x1 minus x2, didn't I? Do you see that? So I went x1 minus x2. Then what did I do? I got a 4 out of that when I subtracted the x's. Then what did I do to get the 16? I did what to it? I squared it. So I square it. Everybody with me? Look, plus. So put a plus here. How did I get that 5? How did I get that 5? I took the y's and I did what to them? Subtracted them. So I took the y1 minus the y2, right? It's supposed to be a 2. And then what did I do with that? I subtracted them and I got a 5. Then what did I do with that 5? I squared that. Now what did I do after I squared them and added them up? I took a big what? Square root, didn't I? So guess what I'm going to do to this? Take a big square root. That right there is your distance formula. That's something that you have to know how to do.
So what answer?
It's basically just Pythagorean theorem, isn't it?
Huh?
All right. How did I find the x? I just subtracted the x's. How did I find the y's? I just subtract the y's. Then what did I do to that x? What did I do to that 4? I squared it. What did I do to the y? Squared it. Then what did I do? Added them up. And then I took a square root. Do you see it? So really, that's all you got to do. So let's put those, let's do this without the graph. Let's go, let's go 3, 2. Did I say anything about using a calculator? Have I even mentioned using a calculator for this? Nope. Don't want you using a calculator. I want you to know how to do this, okay? I don't care. It doesn't matter if it takes too long. I don't care. Take up the time. You got time, okay? Use your time and do it. I'm trying to get you to learn. Thanks.